Okay, so what do a yogurt cup, a thermometer, and an egg all have in common? I mean, if you're just looking around your kitchen right now, you'd probably think they're completely unrelated items, right? Destined for the recycling bin, the medicine cabinet, or, the frying pan. But what if I told you that these everyday, ordinary objects are actually the exact tools you need to unlock some of the most fundamental laws of physics, thermodynamics, and biochemistry?
Welcome to today's Explainer. Our goal today is to create a video from Chapter 7 of the science curriculum and bring it straight into your home. Because, let's be real, science isn't just some static subject that's forever trapped inside heavy textbooks or sterile, white-walled laboratories. It's an active, ongoing, totally interactive investigation of the world immediately around us. So today, we are going to literally transform your kitchen, your backyard, and your living room into a fully functional scientific testing ground. Let's get into it.
Okay, let's dive right into this. Here's our lab schedule for the day. First, sound waves in action. Second, mastering the thermometer. And third, the chemistry of lunch.
Starting off with Section 1, Sound Waves in Action, or Seeing Sound Through Solids.
So, we're going to use the absolute simplest of household tools to prove a remarkably complex physics concept about how mechanical waves propagate. Here is your very first procedure, pulled directly from Activity 11.7. First, you just need to grab 2 empty, clean yogurt cups and about 10 meters of thin thread. You'll poke a tiny hole in the bottom of each cup and tie them to the ends of your thread. Now, this is absolutely crucial. You need to grab a friend, walk in opposite directions, and stretch that thread until it is completely 100% tight. Once it's taut, just speak directly into your cup while your friend holds theirs right up to their ear.
Now here is where it gets crazy. Despite being 10 whole meters apart, your friend is going to hear your voice perfectly clearly. No batteries required. Why? Well, because you've just proven that sound requires a medium to travel, and more importantly, you've shown that it successfully and efficiently travels through solids. When you speak, your voice creates vibrations in the air inside the cup. That vibrates the solid bottom of the cup, which then sends mechanical waves literally speeding down that tightly pulled solid thread right to the other side.
Moving right along to Section 2, Mastering the Thermometer and the Rules of Observation.
Transitioning over to thermodynamics now. Having the right tool is honestly only half the battle. If you observe your data incorrectly, well, you ruin your entire data set. Now, what's really interesting about this is the specific alignment of your eye when reading a measurement. If you look down at a mercury column from above, or if you gaze up at it from below, the glass actually distorts the line. It's a phenomenon known as parallax error. So your eye must be exactly horizontal and perfectly in line with the top of that mercury column to get the true temperature.
So, let's lay down some strict home lab rules based on our methodology. First up, always hold the thermometer perfectly vertically. Second, the bulb has to remain fully in contact with whatever substance you're measuring. If you pull it out to read it, you're just measuring the air in your room. Third, you've got to ensure the temperature range of your specific thermometer is appropriate for the heat you're actually testing. And finally, as we just established, always align your eye perfectly with that mercury column.
Just imagine applying these strict rules to totally different environments. For example, in Activity 14.5, you might be carefully clamping that thermometer vertically into a beaker of water on a nice, stable laboratory stand. But then, in Activity 14.7, you're taking it outside, filling a beaker with earth, and dipping the bulb deep into the soil. The environment changes entirely, right? But your rigorous rules of observation, keeping it vertical, maintaining bulb contact, reading at eye level, those remain absolute, unbreakable scientific laws.
All right, Section 3, the chemistry of lunch, where we go hunting for nutrients.
We are stepping straight into the biochemistry lab now, and we're going to uncover the invisible chemical compounds hiding inside your everyday food. Think of this kind of setup as your ultimate nutrient hunting cheat sheet. In biochemistry, we constantly use specific chemical indicators that change color when they react with certain nutrients. By memorizing this matrix, matching the target nutrient to its test method, and then the expected color result, you can analyze almost anything in your pantry. Let's look at a few of these highly visual reactions in detail.
Just picture this beautiful color spectrum. When we test for simple sugars, like glucose, the solution goes through this striking visual evolution. It doesn't just immediately turn one color. Depending on the concentration and how long the reaction has been going, it shifts. It goes from blue to green to yellow to orange before finally resulting in this thick, brick-red precipitate right at the bottom of the test tube. Seeing that bold, brick-red color is absolute, undeniable proof that simple sugars are present in your sample. But hey, what if you're testing carbohydrates, like starch? Well, for Activity 17.4, all you need to do is boil a little bit of flour and water to prepare a solution. Then you just add a few drops of iodine. Instantly, the mixture undergoes this dramatic transformation, turning a deep, vivid purple blue. That purple-blue reaction, that is the universal chemical signature of starch.
And this brilliantly illustrates our final complex test for today, the Burette test for proteins. By taking a solution of egg white and water and carefully adding just 2 milliliters of sodium hydroxide followed by a few precise drops of copper sulfate, you get a stunning result. The solution turns a very distinct milky purple color. And that gorgeous purple confirms, without a doubt, the presence of proteins in that egg white.
Finally, Section 4, your next experiment, which is testing lipids at home.
Okay, so we've built string telephones, we've mastered precise temperature readings, we've even manipulated chemical indicators. But now it's time for you to apply these practical skills yourself. I'm going to leave you with the absolute easiest, yet one of the most effective, chemistry tests of all, the lipid test. You literally don't need copper sulfate or iodine for this one. According to Activity 17.6, all you need is a plain piece of white paper. You just rub a piece of food on the paper and wipe away the excess. If lipids, which by the way are fats and oils, are present, they're going to leave behind a permanent, translucent, oily patch that lets light shine right through it.
So, I leave you with this challenge today. What other household items could you test for lipids using this simple paper trick right now? Maybe a piece of cheese, a potato chip, a dab of peanut butter? The knowledge is completely in your hands now. I encourage you to take these science principles, look around your home with a totally new perspective, and turn your kitchen into a laboratory of continuous discovery. Happy experimenting!